Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the substituents and their directing effects. The compound has two alkyl substituents on the benzene ring, a tert-butyl group, CMe3, at position 1 and an isopropyl group, CHMe2, at position 4, para to CMe3. Both alkyl groups are ortho-para directors and ring activators. Moving on to the next step. Determine the positions activated by each group. CMe3 at position 1 activates ortho, positions A and D, and para, position B, positions. CHMe2 at position 4 activates ortho, positions A and C, i.e., positions 3 and 5 relative to ring numbering, and para, position 1, already occupied. Moving on to the next step. Identify the position activated by both groups. Cooperative directing position B is para to CMe3, position 1, and also ortho to CHMe2, position 4. This means both substituents cooperatively direct the incoming electrophile, No to plus, to position B. And for the final step, position A is ortho to both CMe3 and CHMe2, making it sterically very hindered. The bulky tert-butyl group especially hinders ortho attack at positions A and D, position B, while ortho to the isopropyl group benefits from cooperative electronic activation by both groups and is less sterically hindered than position A. Position A is doubly activated electronically but severely sterically hindered between two bulky groups. Positions D and C are only singly activated by CMe3 ortho and meta respectively, with D being ortho activated and C being meta deactivated relative to CHMe2. Position B receives additive activation from both groups with less steric penalty than A. Therefore, the correct answer is B. Therefore, the correct answer is option B.